Hello students, this is Harish Konda. Welcome to my channel, The Chemistry Classroom. So before starting the class, I request you all, please keep watching my videos until the last. Why? Because it is very useful to you for your higher education or everything. And don't forget to subscribe and bell also. Why? Because you can see my next videos also. So don't forget to bell. Okay? So the basics we are discussing about the balancing of equation we are discussing. In previous videos, we discussed about hit and trial method. The crude method we discussed. So now we are discussing about the next method. So what is the method that we discuss? So here we have three methods to balance the equation. The first method, hit and trial method. Already in the previous video we discussed. Now we are discussing about the oxidation number method. So the method is called oxidation number method. So with oxidation number method, so we can balance the equation. So how we are balancing? We need some steps. The step by step we balance the equation. So for example here, one compound is there, lead nitrate. So it is reacted with aluminium. So what happened here? The aluminium nitrate is formed and the lead is precipitated. So it is one example for oxidation number method. So in this method, how we are discussing, how we have to balance the equation, now we see. So in oxidation number method, so it is a redox reaction. It is the combination of reduction and oxidation. So it is a redox reaction. In the redox reaction, so completely we need some steps to balance the oxidation number method. So very first step, step 1, that is compulsory we have to calculate the oxidation numbers. We have to calculate the oxidation numbers of the each and every metal, each and every element in the reaction. That is the first one. So here you see the lead nitrate. Here also it is NO3, here also it is NO3. It is in the same form. It is in the same form means the cumulated oxidation numbers are same. So we need not to calculate individually. So here NO3 is -1 completely. Here also NO3 it is -1 completely. Why? Because it is from HNO3 acid, nitric acid. Here from hydrogen, if you eliminate, the NO3 is the anion. How many hydrogens you have? Only one. So you will get -1, NO3 -1. So here is NO3 -1, this is NO3 -1. So here the next one we discuss the lead. Here the lead oxidation number is +2. Why? Because NO3 is -2. We don't know the oxidation number of lead. So it is x minus 1 into 2, that is x minus 2, that equal to 0. From there x equal to +2. So already in the previous videos we know how to calculate the oxidation number. The sum of oxidation numbers are equal to the 0. Based on that we calculated. Here the lead we don't know, it is x, and NO3 is -1. How many NO3s we have? 2. So -1 into 2 -2. X minus 2, that equal to 0. All the oxidation numbers, the sum of oxidation numbers are equal to 0. So x minus 2 equal to 0. From there x equal to lead +2. It is the oxidation number of lead. So here aluminum, it is in the elementary, it is the atom state. The atoms are having the 0 charge. So atom aluminum is 0 charge. Then here the NO3 is -1. Here NO3 is -1. How many NO3s we have? 3. So it is -1 into 3 -3. We don't know the aluminum, so it is x minus 3, that equal to 0. From here aluminum, what it is? It is +3. So same similarly lead, it is an atom. So the oxidation number of atom is 0. So the lead is getting 0 charge. So like that we calculated every oxidation number of the equation. Here the lead is +2, NO3 is -1, aluminum atom it is 0. Here aluminum +3, NO3 is -1 and lead is 0. So like that we calculated. Now we observe the one thing. So one is getting oxidized and one is getting reducted. So what is oxidizing, what is reducting we know. So the definition of oxidation and reduction you know. So if the oxidation number is decreased, that is reduction. If the oxidation number is increased, that is oxidation. Here observe clearly, before the reaction the lead oxidation number is +2. After the reaction the lead oxidation number is +0. So from +2 to 0 it is changed. The change is +2 to 0. That means that oxidation number is decreased. Before it is +2, after it is 0. So what happened here? Oxidation number is decreased. So the reaction indicating the reduction. So what is the reduction it is? The lead becomes 0. +2 to 0. That is reduction. So before the reaction the aluminum is, so in the reaction the aluminum before it is 0. So after it is converted into +3. That means the oxidation, what it is? Oxidation. Why? Because it is increasing in oxidation state. Before it is 0, after it is +3. So this reaction is oxidation. So it is a reaction, reduction reaction and oxidation reaction. So it is redox reaction. So one is reducted and the second is oxidized. So here before the reaction the lead is +2. After the reaction the lead is 0. Before the reaction aluminum is 0. After the reaction aluminum is +3. So here one is reducted and the other one is oxidized. So the first step what we did, so every element we calculated the oxidation number and what you confirm. So in this reaction two elements are going to get oxidized, one is reducted. So one is oxidized and one is reducted. So it is redox reaction. So we have to calculate the step 3. So what we have to do, we have to calculate the decreasing in oxidation state, we have to calculate the increasing in oxidation state. So here before the reaction is 2, after the reaction is 0. That means how many units it is decreased? Only 2 units it is decreased. So the decreasing is 2 units. So same similarly, here before the reaction is 0, after the reaction is 3. So how many units it is increased? 3 units it is increased. So what we have to do? We have to calculate the decreasing and increasing of oxidation state. Before the reaction is +2, it is 0. That means 2 units it is decreased. Before the reaction is 0, after the reaction is +3. That means 3 units it is increased. So that is decreasing is 2 units and increasing is 3 units. That is your next step. And the last step, so what you have to do, you see the reduction. What it is? The reduction, the decreasing of oxidation state. This integer you have to multiply with oxidation compound. So here the 2 units you have to multiply with aluminium. Why? Because here the 2 units it is deducted. The lead is deducted with 2 units. The 2 we have to use here. We have to multiply the 2 with aluminium. So the decreasing, so we have to multiply with oxidation compound. Same similarly vice versa. The oxidation change, that is 3 units, you have to multiply with the reducting compound. So here what we are doing, so the reduction we are multiplying with oxidation reaction. So same similarly the oxidation, what it is oxidized, so that we have to multiply with the reducting compound. These 2 integers you have to get same and the remaining you have to balance. Here you see, here before the reaction we have 3 lead compounds. So there you have to multiply with 3. Why? Because here we have 3. So I am multiplying with 3. Same similarly here we have 2. So I am multiplying with 2. So now we check whether the reaction is balanced or not. You see here 3 lead, here also 3 lead. So here 2 aluminium, here also 2 aluminium. Now we calculate about the nitrates. So here 3 into 2, 6 nitrates. 2 into 3, 6 nitrates. So in the reaction, everything is balanced. Here before the reaction is we have 3 leads. So after the reaction also you are getting 3 leads. Before the reaction you have 2 aluminiums. After the reaction also 2 aluminiums. Before the reaction 3 2 just 6 nitrates. After the reaction 2 3 just 6 nitrates. So the reaction is balanced. This method is called oxidation number method. So in this method, very first we have to calculate all the oxidation numbers of the each and every element, and you can identify only two. The one is getting reducted and the other one is getting oxidized. So you have to mention the reduction reaction and oxidation reaction, and you have to calculate how much it is reducted, how much it is oxidized, how much it is decreasing in oxidation state, how much it is increasing in oxidation state, so that we are calculating the decreasing in oxidation state and multiply with oxidation compound, the increasing in oxidation state and multiply with reducting compound. The two I am keeping same only. The remaining equation I am balancing. Here we have 3 leads, so here we have 3 leads. Here 2 aluminium, so I multiply with 2 aluminium. So automatically the reaction is balanced. 3 2 the 6 nitrate, 2 3 the 6 nitrates. So like that we balance the equation with oxidation number method. Okay? And the next video we discuss about the off reaction method or ion electron method. That is very important for your examination. So keep on watching. Don't forget to subscribe, like, share, comment and subscribe and bell also. Thank you.